This is file WB7.1. We're going to illustrate how to use at-risk to create Monte Carlo simulation models. At-risk is now loaded. We have a bit of data on this tab. Here we have the order quantity, which is the current policy that we want to test. We have the reorder point, which is 75 units. We have the profit for every one of the items sold. We have the ordering cost, and we also have the inventory holding cost of 25 cents per unit day. In the second tab, we have the deterministic model. And by deterministic, we mean that the demand used every single day of the year is 20 units. We know that that demand varies according to a normal distribution, and we will consider that as we move into the probabilistic model. The purpose of doing this is to allow us to build the logic of the model and move on to the probabilistic model later, once we are able to test the logic of this one. Let's go through day by day here. This is the first day of the year. We were told that the inventory that day was 125 bottles. We know that the demand for that day under the deterministic situation is 20 units per day. Because we have the inventory, we're able to sell. We don't have any deliveries expected for that day. We close the inventory at 105 units, which is the difference between the 125 we had when we opened the inventory and the units sold, and the 0 deliveries. So it's B6 minus the 6 plus E6. So we're seeing here an operation being simulated using logic. Because we haven't reached the reorder point of 75, we don't place any orders. We don't have any pending orders. Because we sold 20 units and we made $10 per unit, we have a profit of $200 that day. Because we placed no orders that day, we have 0 order cost. Our inventory is 26.25, and that equates to the closing inventory of 105 units multiplied by 25 cents, which is the cost of inventory. The net profit then is the profit from sales minus the order cost minus the inventory cost. So we have $173.75. As we move into day 2, we start the day with 105 units in inventory, and that is coming from the previous row, from F6, which is this number here. Our demand, still 20 units that day. Because we have the inventory we are able to sell. We have no deliveries planned for that day. We close the inventory at 85. We don't place any orders because we're still above the reorder point. We have no pending orders. We sold 20 units, so we have $200 of profit from sales. We have no order cost. And we have $21.25 in inventory cost resulting from the 85 units we have in stock. Our profit that day increased to $178.75, simply because our inventory cost was reduced. When we move into day 3, we have 85 units in inventory. We are able to sell 20 of them. We have no deliveries that day. We close the inventory at 65. Because we reached the reorder point, we ordered 250 units. Then we have orders pending for 250 units. The profit from sales is $200. We spent $50 placing that order. Our inventory cost is reduced drastically, simply because we only have now 65 units. And our net profit is $133.75. The next day we open up with 65 units. Our demand is 20. Our sales is 20. Our deliveries are 0. We close the inventory at 45. We place no orders because we have orders pending. We have 250 units in transit to us. Our profit from sales still $200 because we sold the 20 units on demand. We did not place any orders this day, so we have no expense on that item. And then our inventory cost goes down to $11.25 because we only now have 65 units. Our total profit improved to $188.75. The next day we start with 45 units, we sell 20, we have 0 deliveries, we close the inventory at 25, we place no orders because we have orders in transit. Profit from sales is still $200. Again, no order cost. Our inventory costs are very low, so we actually have a very good day sales wise. The next day we open the inventory at 25, we sell 20, and we close the inventory at 5. We have a profit of $200 from sales plus $1.25 expenses in inventory. Our profit reaches the maximum level of $198.75, all items included. Next day we open at 5. We have a demand of 20 units, but we can only sell 5 because we are short. We have no deliveries that day. Inventory closes at 0. We order nothing because we have an order coming. We have $50 in profit for the first time. We had lost sales. We have no order cost, no inventory cost because our inventory is 0. Our net profit is $50. When we go into the next day, we have 0 inventory. We have a demand of 20. We cannot sell anything because we don't have it. But fortunately, at the end of the day, we received the 250 units ordered 5 days ago. The inventory then is $250. So we have our worst day. We have no sales, and we have to carry the cost of inventory of $62.50. The next day we have inventory of 250. We have a demand of 20. We're able to cover that demand. We have no deliveries. We close the inventory at 230. So we have a profit of $142.50. This goes on for 365 days. So we complete the year, and then we look at the profit obtained day by day. And if we keep that policy and demand is steady, exactly at 20 units per day, we will have a total profit selling this item of $52,845. If we change the policy, we decide to order, for example, 350 units, and the reorder point is now, we do that every time our inventory level reaches 100 units. We go back to the deterministic model, all the values are adjusted. So now we see that the orders are $350, and we only place the order once we reach a certain level of inventory. So we reach, here it's below 100. When we look at the bottom line, we see that our profit increased slightly to $53,620. And we can test other alternatives. I'm going to go back to the 250 and 75 as we started this.